the next pair of slides go together. They're kind of like yin and yang. So we talked about surface high pressures, so I'll just go put an H here, surface high pressures. And remember, there's 3 reasons you might have a surface high pressure. But however you have a high pressure, we call that an anticyclone, surface high pressure. And surface high pressures, like I said, generally have their isobars are generally kind of blobby and a little bit spread out. If they're spread out, they have a kind of a small pressure gradient force that gives you wimpy wind. And now, we talked recently about the Coriolis force, and the Coriolis force works on large bodies of air, such as you would have, for instance, around an anticyclone. And so if we have a high and low, you would expect wind to go this way, right? So, but deflection to the right, and we actually have wind going this way, okay? So actually you can kind of see this wind moving around this high in what? A clockwise motion. Clockwise motion around an anticyclone. Cool. So another thing about high pressures, central high pressures, is that if you have high, okay, you have basically air that's kind of moving out of the area, okay, and what that creates is kind of a void in the central high, and so I can't show it, but you have air actually from a loft at upper elevations that is kind of coming down, okay, and that descending air we talked about. I think we talked about this cooling air, if it rises, and if air is forced down or coming down like that, actually will warm. And so oftentimes in an anticyclone, you actually have nice warm air, and that warming air will not condense, so it'll be clear, light winds. Okay, that's what we call anticyclonic weather system, kind of these high pressures. And contrast that to a low. Now, if you have a central low pressure, okay, in that case, if this is a low, we have high out here, so we must have wind going from the outside in. Again, deflection is to the right, so we actually have it going kind of like this, okay? So it makes a loop around it, what? Counterclockwise. This weather system is called a cyclone. Sounds like a twister, right? Cyclone. Okay. So again, deflection is to the right, and it causes it to go counterclockwise like that. So if you have a low pressure, basically you have air kind of meeting up here, okay? And as the air meets up there, it becomes kind of squished together and it rises. And we talked about different lifting or rising mechanisms making air go up and expand and cool down. So actually this is one way that you can oftentimes have cloudy skies associated with a cyclone, a central low system. And also remember I said those isobars are pretty close together, creating that strong wind, and you'll generally have cool conditions.